industries, you all know that automation is one word which has been derived from the word control. And control is the basic requirement for any system which needs an output, and that output is the desired one. Whenever you want to have a desired output, you want to control the system, because otherwise you know that the system can be an open loop system, it can be a closed loop system. Session before you. What one can learn after automation? Let us see. What is automation? First of all, a person, a participant who participates in this particular type of sessions or courses will learn what is automation. Number one, what are the basic elements of automation? Why automation is necessary? What are the different technologies available for bringing in automation? Illustrations of automations. What are the different controllers? What is SCADA and DCS? How communication is playing a vital role in the process of automation? What are the different protocols used in automation? And what is the hierarchy of automation in real practice? These are some of the things which form the learning objective of this session. Contents, what this session is going to contain. What is automation? A role of automation in the different industries. Why automation? It is the advantage. Automation has got certain advantages or merits, and that is why automation is preferred in processes. Whether in industry or in domestic, automation has its own applications, it has its own merits, and it has its own importance. How significant is automation? And that is the advantage. The basic elements of automation. What are the basic elements of automation? Suppose you have to have a process which needs to be automated, then there are certain elements which are the basic elements, and that form the total automation process. We can name them such as sensors, LVDT, thermostat, thermistor, pressure measurement, CT, PT, limit switches, magnetic pickups, capacitive sensors, etc. I mean, we can name many more also. Then controllers are control-based system. Controllers are controller-based system. Actually, controller, when I say controller, it is a whole system. And that is definitely a controller-based system. Actuators, the relays, the solenoids, etc. These are the examples of actuators. The types of controllers, proportional control, PI, that is proportional integral control, proportional integral derivative control, and the categories of controller. These are the three processes, control processes, and there are different types of controllers. They can be categorized. The DCS and SCADA is very, very important. DCS and SCADA both are very important and very much used in the industry, especially in the power industry, in manufacturing industry, in any kind of, in your assemblies, all kinds of industries, they are used DCS and SCADA. So what is SCADA? We'll see it elaborately. How communication has enhanced automation. Communication has played a very, very important role. It has played a very important, significant role in the field of automation that we'll see. Then common protocols, CAN, Modbus, Profi, substation automation protocols, 61850, etc. These are the common protocols which we'll talk about. When and how to go for automation. Now, automation is required, basically required when it is required, and how automation is implemented. That's very important to know. Design of an automation system. A system, when you want to make it automation based or automotive system, then you have to design the system. So that is also very, very important. Automation myths, impacts of automation, etc. How automation affects economics. This is a very vital point. Whenever you talk of automation, means लोगों की छटनी होगी. People may lose their jobs. People may number of people may be reduced in a job. So that is a effect. That is a bad effect of automation. So economics, it is increasing, no doubt. Economically, automation is very, very enriched. But to some extent, it has job propagation is very difficult. How automation affects the economics, that's very important to know. Then hierarchy of automations, and finally we'll have certain queries. Let us elaborate. So first of all, I like to define what is automation. The dictionary meaning defines. How does it define the dictionary meaning of automation? It says the technique of making an apparatus, a process or a system operate automatically. When there is a system or a process and it works automatically, we say it is automation. The American system of definition is automation. Federation define automation as the creation and application of technology to monitor and control the production and delivery of products and services. This is the Automation Federation of America. They define automation like this. So automation means use of available technologies to reduce the need of human efforts. Automation is a step beyond mechanization. You can say that it is not mechanization, it is a step beyond mechanization. And mechanization provides human operators machinery to assist themselves with the muscular requirements of work, while automation greatly decreases the need for human sensory and mental requirements as well. So this is in a nutshell the definition of automation. If you see it in diagram form, we see that automation is basically the delegation of human control function to technical equipment. For example, you have plant, so quantity is increasing, productivity is increasing, but manpower cost is decreasing. So this is automation. Suppose the plant is not automated, quantity, if you want to increase the productivity and quantity, manpower is also to be increased. But in automation, quantity will increase, productivity will increase, but because of automation, the manpower cost will be decreased. This is in a nutshell the automation and its objectives. So automation cycle, what is automation cycle? Let's see. It senses the inputs, processes the logic, and causes the desired outputs. In diagram form, we can say that there is a controller, there is a machine for process, there are outputs, and there are inputs. So this is in nutshell the block diagram of an automation cycle. History. Let us see a little bit of history of automation. Ancient world versus the modern world. Of course, you can define, you can coin your own words, but to some extent, I have tried to put them in ancient world, what was automation history, and how this modern world has taken automation in its application. In ancient world, we have manual control, pneumatic control, hardware logic control, electronic control using logic gates, process instrumentation, etc. But here in modern control or modern control, which is nothing but automation, we have programmable logic controllers, microcontroller based embedded controllers, cluster of controllers, and master controllers of at remote and intelligent instrumentation. This is in a nutshell a history given for automation. The major milestones in technologies. Let us see what are the major milestones in technology. In ancient world, about 8000 BC to 330, the Middle Age through 1599, the age of scientific revolutions came in 1600 to 1790. Then the Industrial Revolution came. The Industrial Revolution took place within a period of 1700 to 1920. The Electrical Age followed, that was there in 1891 to 1934. The Automatic and Electronic Age reached the place in 1935 into 21st century. We said that we have appeared into 21st century. out of which last 20 years belong to communication and information era. This is a very, very important point because the last 20 years we have been working very severely in the field of communication and information. If you see the ancient world, what are the examples? The invention of that goes in the ancient world. Then came the discoveries of various metals. Then came in the age of scientific revolutions, 1600 to 1790, the invention of glass took place. That was a very, very, very invention, good, I mean, important invention. Then it followed the industrial revolution, 1700, 1920, the discovery of electricity. It was the denting point. Innovation of telegraphy, right? Telephones. This was electrical age 1891 to 1934. And then came the invention, the automatic and electronic age. How this is emerging, the control or the automation is emerging like this. Here in this era, the 1935 into the 21st century, out of which I said the 20 years belong to communication and information era. Here we have good inventions like invention of transistor. It was 1948. Invention of microprocessors. Of course, in between you had thyristors, etc., IGBTs, etc. We had invention of microprocessors. We had invention of mobile technology, and we further had invention of internet technology. So this is how the modern control has taken place and the automation has reached the sphere. Then a range of technologies involved in automation. There are a versatile range, all sort of ranges are there. To name a few, automation involves a very broad range of technology, including number one, robotics and expert systems. You know what is an expert system? An expert system is a computer system that emulates the decision-making ability of a human. It emulates like a human being, so it is known as an expert system. Then telemetry and communications, electro-optics and cyber security, then process measurement, instrumentation and control, smart sensors and transducers, wireless applications, systems integration, test measurements, and many, many more, many more. So these the way how you can show the range of the technologies involved in automation. A lot of technologies are involved in the range of automation. To show an example, this is a robot. And here you can see that this robot has played a very significant role and it has reached the field of automation. Application of automation. Automation encompasses many vital elements, systems, and job functions. Manufacturing, transportation, utilities, defense, facility operations, etc., to name some of them. And many others, many more, right? So these are some of the applications of automation. Automation can be said that it is everywhere. It is everywhere, present everywhere now. The automation in all functions and places. We have aerospace, we have automotive, chemical and petroleum, computer technology, construction and design, electro-optics, environmental, food and pharmaceuticals, glass and ceramics, management, marketing and sales, mining and metals, nuclear, power distribution, process measurement and control, pulp and paper, robots and expert systems, safety, sensor technology, systems integration, telemetry and communications, test measurement, textiles, water and wastewater, wireless applications. I don't think any sphere is left in the field of automation. Automation has touched every sphere of this world, and it has almost come in every day-to-day life of our day-to-day life, and so we can see the significance, the importance of automation. Now, let us see what is the impact of automation. Impact means automation has got no doubt, it has improved the technology, it has improved accuracy, it has improved your preciseness, it has improved economics. All those things are there, but there are certain demerits also. Let us see automation has a significant impact in the wide range of industries, including manufacturing industry. One omnipresent telephone operator have ceased the exist as telephone exchange were automated. Now this person was required everywhere when there was no automation in the telephone exchange. But now this man has almost lost his job. He is not much required. So this is one impact, or you can say a bad effect of automation. But the advantages are many more. They are much more than such effects. Automation has been responsible for the shift in the world economy from industrial jobs to service jobs in the 20th and 21st centuries. ATM have reduced the need for bank visits to obtain cash and carry out transportation. This is one burning example here, that earlier people used to visit the banks for every reason. They had to go to the bank, right? For cash money, for depositing something, to get the money back from the bank, etc., etc. But now ATM has solved to some extent that this bank going, the visiting bank has become very less. So this is one more advantage, and I can say that automation has played a very significant role so far as banking is concerned. You have online banking. Online banking was earlier not there. This is an example of automation. When you didn't have online banking, what was happening? You didn't have online banking means you had to go to the bank will send it to your bank, that may be out of station somewhere. It will take a lot of time, 2 to 3 days, 3 days, and sometimes there is a missing also. Your check may be missed, your draft may be missed, and your money may take place very long time to get back your money. But now it is online, so that is one wonderful example of automation, wherein banking has become very simple and easy. Now, certain impacts or effects, I would say, of automation. As a result of increase in automation, which is ever increasing almost every field as a result of ease in use of new technologies, the nature of jobs is getting affected. Why? How? Telephone operators, stock market agents, railroad brake signals, switch operators, shoe and leather workers, photographic processes, workers and processing machine operators, model makers and pattern makers. You see, because of the latest technologies, because of the automation taken by the latest technology, many times these people are losing their jobs and they may not be required. Telephone operator may not be required. It is all computerized. It is all automated. So the operator is not required. So that particular post is not there. It is gradually going away. So that is one effect, I would say. It's a negative effect. Stock market agents. There used to be some jobs with the stock market agents, but slowly and gradually, since it is becoming online, since it is becoming automatic, the people are losing their bread and butter. Similarly, railroad brake signals, shoe and leather workers, photographic process workers, machine operators, model makers, and pattern. So there are certain effects, no doubt, but the merits are so much that automation cannot be denied, and it is the talk of the day. It is the requirement of every system everywhere. How much automation? Now, it is a very point to be debated, that if you require automation, how much automation do you require, right? So automation represents one of the major trends of 20th century, as in many cases, automation has provided extended system functionality well beyond existing human capabilities. Contrary to the application of the term automated, humans have remained a critical part of most automated system, as most automation has been piecemeal, covering certain functions but not all the functions. Human beings have remained in the system as integrators, monitoring and automation for some functions and performing others themselves. Here I would like to quote an example of automation in medical sciences, and the latest one is surgery. Now you have robots. The robots are carrying out very critical and complex surgeries like brain surgery, heart surgery, etc., bypass, etc. And they are doing it very efficiently also. But even then, a robot may be costing crores of rupees to perform that operation. Well, it is all right, but a team of doctors need to be there. They have to be there because it's a very, very critical situation, critical operation surgery which is being carried out by a robot. So always there is a team of doctors who will take care and who will try to monitor what is happening. So this is one example here. Then there is another example, I may say, that the robots have also done wonders in the areas of automobiles. So take the example of our Indian this thing, which is Maruti, and I have personally visited Maruti Udyog in Gurgaon, that they are using such robots which can perform 8 to 10 operations simultaneously, one by one. They do it, and it's a total automatic process. And their unit in Japan, they can change the head also. They change the head and they do some different processes. So this is the level of automation which has come in the picture. Full automation of the work task may be technically possible, but it may not be desirable if the performance of the joint human-machine system is to be optimized. Intermediate levels of automation may be preferable for certain tasks in order to keep human operators situation awareness at a higher level and allow them to perform critical functions. It is the same thing what the example I gave as the surgery being carried out by a robot. Now, level of control. One way to minimize the negative effect of automation is to devise implementation schemes that keep the human beings actively involved in the decision-making loop while simultaneously reducing the load associated with doing everything manually. I think it is self-explanatory. Whenever you have the human touch in it, you have to have some implementation schemes that will definitely improve the automation system, but at the same time the human touch is there. Examples, let us see what are the examples of automation. Common examples of automation are day-to-day life, if you see, and industry, if you see. Day-to-day life, you will see automation examples of ATM, starting of the vehicle, automatic washing machines, electrically driven pumps, UPS, and so many others. So many more others. Industry, painting robots in the automobile industry, soldering machines, DCS distributed control systems, SCADA, and AMF generators. These are examples I would like to give here. Then technology is involved in the working of ATM. Communication.
चेंज करेगा
potential transformer, again CT like that, you also have potential transformers, and that is measured for having the potential difference, having many primary turns but few secondary turns. In step down, the voltage decreases and current increases. Thus, voltage can be easily measured by using low range voltage. The voltage is stepped down in known ratio called voltage ratio. And if you see the construction of a PT, it's slightly different than CT, because here your objective is to measure the potential difference. So it is, the transformation ratio is V2 by V1. There it was I1 by I2. This is the one switch yard. Again, you can see the PTs here, the longer ones, and CTs were slightly conical ones, and this is cylindrical type. Precautions for CT and PT. What are the precautions? Utmost care should be taken to ensure that CT secondary is never open. Okay, this is a very, very important thing. For safety purpose, the secondary should be completely insulated from the high voltage primary, should be in addition grounded. There should be more than one ground. This is a very, very big precaution for CT and PT. Automation and electricity demand. Now you know that automation has always been a very, very important thing so far as electricity is concerned. It's very, very important. In the near future, home automation systems may be linked to the electricity utility in a number of ways. Then householders can then program appliances to reduce the power or switch off altogether during the high price. There are different methods, there are different switches wherein you can switch off your gadget when there is a high price. You know that the tariffs are different. Sometimes it is high, sometimes it is low, sometimes it is flat. So if you want that your gadgets to be switched off during the high price tariff, then it can be done. Alternatively, householders would enter a supply contract that allows the electricity supplier to signal equipment controlled by the home automation system, such as air conditioner, to turn off certain equipment for short periods. You know, AC is one of the gadgets in your house which consumes a lot of electricity. So if you have an alternative householder, you have a scheme like that, you can switch off your AC accordingly, and you can reduce your electricity to quite a lot. So householder may choose to participate and obtain lower electricity prices or other financial benefits. Now, desirable sensors attributes. What are the attributes of a sensor? Which are desirable. One is reliability, then accuracy and repeatability. Accuracy is different, repeatability is different. I hope you understand the difference, accuracy and preciseness. Good response time, withstanding capability, long life, and less electricity. These are the desired attributes of a sensor. And this is the example of repeatability. You can very well, it has been illustrated, repeatability and accuracy. I hope you understand the difference between the two. Now, there is a word called transducer. There is a very, very common word called sensor. But there is a difference between the two. So I can define it here. The sensor, it senses any form of physical quantity in that form, same form. So suppose there is a temperature, heat is to be sensed. So it will sense it in the temperature will be sensed. It will be in degree Celsius or degree Fahrenheit, whatever it is. So that is a sensor, say thermometer, tachometer, odometer, etc. These are the examples. But transducers, on the other hand, it senses a physical quantity and simultaneously converts it into electrical. For example, LVDT, tachogenerator, load cell, and many more. All transducers are sensors, but all sensors are not transducers. You see, transducer is a combination of two sensors, you can say, primary sensor and secondary sensor, or primary transducer and secondary transducer. Primary transducer is nothing but a sensor, and the secondary transducer is a transducer which converts that particular quantity into equivalent electrical signal. Commonly used sensors for industrial applications. Information from the sensor transducer can be of two forms, analog and digital. The LVDT, pressure transducer, strain gauge sensors, magnetic sensors, piezoelectric sensors, photoelectric sensors, limit switches, relays, auxiliary contacts of switch, contact, breaker, etc. These are some of the examples where very commonly used. Sensor used in the industry. Industry, you may use thermocouples, proximity sensors, limit switches, RPM sensors, CTPT, current and voltage transformers, then Rogowski coil for measuring very slow changing current. Use frequency is very less, say 1 hertz or so. The Rogowski coil is used. Then 4 to 20 milliampere transducers, current, voltage, frequency, kW, kVA, kVAR, PF, phase angle. Basic elements of automation. There are controllers. Now, what is a controller? Let us see. Controller is a device which monitors and implements the required changes in the operational conditions of a given system. Controller is a transfer element which compares the feedback value received from the transducer sensor to a predetermined value, that is set point, and processes it in such a way that a control signal is transmitted in the form of an appropriate variable to the actuating element. Anything which is controllable must be measurable and comparable. This is very important. Nothing can be controllable if it is not measured, if it is not compared. So anything which is controllable must be measurable and comparable. Comparator compares a given value with a set value. There is a set value or the reference value, whatever you may call it, and you compare it with that value and then said that this is the standard value or this is the comparative. This is the value which is required. The symbol, what is the error? How much is required? How much is to be implemented, and so on. The simplest controller is an op-amp comparator. That's the simplest form. Of course, simplest form of a controller is on-off switch, and op-amp is the device which is supposed to be the simplest comparator. Further, a device which accepts the inputs, measures them, and depending on the predetermined conditions, actuate one or more devices is called a controller. These are the certain definitions of controller. Input signal which represents certain physical quantity can be digital or analog in nature. An automation form, the sensor, is to be converted into electrical form by signal conditioners and amplifiers before it is processed by the controller. It is a must. It has to be changed into electrical signal. Why? Because anything in the automation system, finally we are going to play with the signal, and that has to be compared in the form of electrical signal. That's why a conversion of any quantity into electrical signal is a must, and that's why transducers are much used. If the automation is analog, then a suitable ADC is used to enable the controller to read the transmission. Of course, nowadays digital controllers are there, wherein we have to change it into a digital form by using ADCs. But finally, when the control element is to execute the work, actual function, then it does not recognize the digital signal. It has to be further converted into analog signal by using a D2A converter, that is DAC. Programmable automation controllers. Now this is a combination of programmable means it combines the features of capabilities of a PC, this computer, and a control system. That's why it is known as PSC. It is a compact controller that combines the features and capabilities of a PC-based control system with that of typical programmable logic controller, PLC. If you combine it, it becomes PSC, Programmable Automation Controller. PSCs are most often used in industrial settings for process control, data acquisition, remote equipment monitoring, machine vision, and motion control. These are the places where PSCs are mostly used in industries. Types of controllers. Controllers can be categorized based on parameter or physical quantity they are controlling. Examples are temperature controller, RPM controller, pressure controller, etc. And the second is the manner in which they are controlling the physical quantity. Proportional controller P, proportional integral controller PI, proportional integral derivative controller PID, and on off, that is also known as bang bang. It used to be known as bang bang. And we all know that whenever the simplest form of a controller is the P type controller, then comes the PI type, and the most complicated is the PID type, wherein a derivative is also introduced. Analog or digital controllers, and then lastly the device used for controlling PLC, PC computer, digital circuits using, which is I said as PAC. So controllers are essentially small purpose-built computers with input and output capabilities. How you say controllers are essentially small purpose-built computers with input and output capabilities. These controllers come in a range of sizes and capabilities to control devices commonly found in buildings and to control subnetworks of controllers. Inputs allow a controller to read temperatures, humidity, pressure, current flow, air flow, and other essential factors. The outputs allow the controller to send command and control signals to slave devices and to other parts of the system. Inputs and outputs can be either digital or analog in nature. Now comes the microprocessors and the world of microprocessors and microcontrollers. Microprocessors are these days being replaced by microcontrollers. So we'll not talk much about microprocessors, but the microcontrollers. Little bit of microprocessors first. Selection criteria for controllers: speed, memory, input-output handling capability, communication capability, and built-in features in built ADC and built DAC. This is the Intel series. We know that Intel is one of the companies most important, most significant companies who have played a very vital role so far as microprocessor world is concerned. So 4004, 8008, 8080, 8085, 8086, 80136, 80286, 80386, 80486, 486, DX4, and Pentium, P3, P4, 32 and 64-bit microprocessors, and these are finally the processors available. And the operators are operating system, Linux and variants, and then IBM, Unix, Windows. There have been so many versions, and Windows 8 is now reached. So there are the operating systems for these microprocessors. Programming, little bit of programming of microprocessors, because you have this world in front. Controller chip without a software loaded in it has little power to control, because if you don't have the software, if you just have the hardware, it will not do any good. So you have to have the backup software. A controller understands only zeros and ones. It can only distinguish two levels, high and low. The lowest level language is machine language, which has only two characters. The Morse code is perhaps the best example of machine language. Assembly level language people depends on the type of the controller. Each controller will have a fixed number of instruction set. The highest level languages are those in which human beings communicate. There are many higher level languages depending on the type of the application for which they are used. Examples are Fortran, COBOL, BASIC, Fox Pro, etc. And compilers and assemblers are C, C++, Java. So types of instructions: input, output handling, assigning, mathematical instructions, logical, repetitive, and branches. A building automation system, BAS, they call it BAS. It is self-explanatory. You have human interface device, computer, then you have the web server, you have programmable logic controllers, you have different central plant controllers, boiler controllers, package units, lighting controllers, DAC unit devices, talk devices, etc., etc. And then finally you have VAV boxes as outputs. Industrial automation process and control. You see, you have batch processing and you also have continuous processing discrete, and you have discrete also. In practice, an industrial automation process control system can be characterized as one or more of the three types, which is batch, continuous processing, and discrete. Batch processes are used to produce a relatively low to intermediate quantities of product. The batch processing applications that require specific quantities of raw materials combined in specific ways for particular durations to produce an thermo intermediate or end result. Examples: production of adhesives and glues, mixing of raw materials in a heated vessel, then form a quantity and end product. Production of food, beverage, and medicine. PCB assemblies. These are some of the examples wherein you can have batch processing. In continuous and discrete system, continuous process used in industrial automation applications produce very large quantities of product. When there is a very large quantity of product to be produced, then continuous process is required. Examples: the control of the water temperature in a heating jacket this is an example of continuous process control. Some examples of continuous process are the production of fuels, chemicals, plastics. Discrete, you go for discrete. It is found in manufacturing, motion, and packaging applications. The examples are robotic assembly, commonly found in automotive production, can be characterized as discrete process control. Most discrete manufacturing involves the production of discrete pieces of product such as metal can. This is a supervisory control and data acquisition system, SCADA. SCADA is defined as refers to a system that collects data from various sensors at a factory, plant, or in other remote locations, and then sends this data to central computer, which then manages and controls. SCADA focuses on gathering and circulating the right amount of system information to the right person or computer within the right amount of time. You see, SCADA is very, very important from many industrial point of view. For example, one of the best applications of SCADA is in thermal power generation, actually, wherein you have a lot of controls, lot of loops, lot of monitoring, and that used to be done in one place only earlier, which was wired, but now it is SCADA fully wireless is available. You also have it in cement factories, in a lot of manufacturing industries, all are using SCADA at a very large level. But there is another word called DCS, distributed control system. If you have DCS and SCADA, DCS is a very broad term used in a variety of industries to monitor and control distributed. SCADA is an autonomy for supervisory control and data acquisition. SCADA systems perform data collection and controls the supervisory level. Some systems labeled as SCADA perform the data acquisition only. A SCADA system should not be critical to the control process. The SCADA concept connects to a PLC or real-time device. So there is a separate or integrate real-time automated control system that responds quickly enough to compensate for process changes within the time constants of the process. The SCADA controls and monitors the process, but the process must also run independently from the SCADA system in case of failure. Suppose there is a failure, then it should not wait for the SCADA. It should run automatic and in its own way also. That is the beauty of SCADA. Features of SCADA. What are the real features of SCADA? Important features. Features of typical SCADA software: dynamic process graphic, real-time and historical trending, alarms, recipe management, security, device connectivity, and database connectivity. Role of communication in automation. Now, I was telling you earlier that communication has played a very significant role in the field of automation. Let us see what does it play. Communication has played a vital role in the process of automation. The controllers receive the input from the various sensors and also receives the input from the communication bus. So there have to be a lot of protocols, etc., involved in communication. Master control is usually at the at the centralized location, and in it must receive data from all the locations to enable it to do process the inputs and reach to the decision. If it is centralized, then only it will receive all the inputs at a time at one place, and then it will process it to get the required output. Different protocols are used to transfer the data to the controller. This I was talking about. A lot of protocols are being used for communication. Now, what are the different protocols? IEEE instrumentation bus, CAN bus, Modbus, Profibus, 61850 protocol, TCP/IP. These are the commonly used and very popularly known protocols which are used, which are practiced in industrial automation. The basic elements of automation. Actuators, very, very important. What is an actuator? Let us see. Definition for an actuator: a mechanism that puts something into automatic action. That is known as actuator. Which puts anything into automatic action is the actuator. As the name suggests, it actuates. An actuator is a mechanical device for moving or controlling a mechanism or a system. If the actuator is not there, then the mechanism will not take into action, and naturally there will be no automation possible. An actuator can be said that is an integrated part of an automation. An actuator is operated by a source of energy, usually in the form of an electric current, hydraulic fluid pressure, or pneumatic pressure, and converts that energy into some kind of motion. How does it work? It may work hydraulically, it may work pneumatically, or it may work electrically. So that kind of signal it is received and it is driven like that, and then it will start the mechanism. The actuator is meant to start the mechanism. Different actuators used to control the given system are relays, solenoids, valves, motors, and contactors. In addition to above types of actuators, the system can be controlled by a digital signal also, generated locally or received from remote and device through communication channel using a certain protocol for the communication. That is also possible. So these are the examples of an actuator. As I said, relay, solenoid, valves, motor, and contactors. Actuators can be categorized. How you categorize? Number one, it can be energy source based, and the number two is type of motion. So if you see the energy source based, then electrically operated actuator, pneumatically operated actuator, hydraulically operated, and sometimes gas operated also. So these are the types of electrical energy, energy source based actuator. And if you see from the type of motion point of view, then you have linear motion, you have rotary motion, you have oscillatory motion, etc. Alright, this is, if you see, this is the most common type of actuator, is powered by air. The pneumatic cylinder are also known as air cylinders. And air cylinders are airtight cylinders typically made from metal that uses the stored energy of compressed air to move a piston from the air when the air is released or uncompressed. They are most commonly used in manufacturing and assembly processes. There you have the air cylinders, and that is known as pneumatic actuators. Grippers, which are used in robots, use actuators that are driven by compressed air to work much like a human finger. Relay is an electromechanical device, and that has a pre-designed operating voltage. Whenever that voltage is given, that particular current is passed through it, and it becomes electromagnetic and starts working. Essentially, it has a coil, a plunger, a spring, and at least one pair of stands operations. Coil gets energized, and electromagnetic action as a result of current flow in the coil attracts the plunger, resulting in the change of contact positions. It attracts, the plunger gets attracted, and naturally it breaks or opens. It either breaks or it closes. So that is a change of contact position. Contacts are designed to carry large current compared to the operating current of the coil. Contact material can withstand several thousands of motions. If it cannot be, it is unable to withstand that, then it will get pitted and its life get limited. So that's why it has been designed such a fashion that it can withstand several thousands of operations, make and break, nothing but make and break operations. The relays are available in different types, sealed and unsealed, latching, non-latching, AC, DC operating. The contacts available in the relays are NO and NC, that is normally open type contact and normally closed type. If it is a normally closed type contact, when you energize it, it becomes open. And on the other hand, if it is an NO type, that is normally open type, when current starts flowing, it is energized, then it becomes closed. Relays versus contactors. How do you compare the two? Contactor again works on the same principle. However, contactor has two types of contacts, main contacts and auxiliary. Auxiliary contacts are used to give the status to the controller, while main contacts carry the control current. This is the difference. And contactors are available in different sizes depending on the current carrying capability of the main contacts. Solenoid. Solenoid is also a solenoid also operates on the principle of electromagnetism like relay. However, in addition to changing the status of the contacts, solenoid plunger movement also initiates mechanical movement, leading to change the positions of the other mechanical components to control the pneumatic, hydraulic or electric. Now there are stepper motors examples. You must have seen stepper motors, and stepper motor, one of the most important application of stepper motor is your printer. Used in measured rotation, can be held at a particular position of the shaft, ideal of many automation robots requiring higher precision, etc. Servo motors, these are certain motors, small motors used in closed loop control systems in which work is the control variable. An integral feedback device or device and tachometer, encoder and tachometer are either incorporated within the servo motor or are remotely mounted, often on the load cell. Now, automation structure. If you see what is the structure of an automation look like, although applications other differ widely, there is little differences in overall architecture of the control system. Why the automation system of a power plant is not sold also for automating a brewery depends on largely on small differences. It cannot be same automation. Automation structure has to be different for different purposes. For example, explosion proof devices. Availability 24 hours operation and hot repair on regulations. For example, Food and Drug Administration and also tradition customer relationship. The biggest distinction is the domain known how embedded in the control system. So this is how you have to define what is the application. This is large control system hierarchy. Okay, this is very, very important. Industrial point of view, say there are administrative and enterprise. These are the top, and low level is there. Low level, you have the primary technology which we call at zero level automation. Then we have the first level automation. From the bottom, if you go, the zero level, that is the primary technology is being used. All these primary technologies are in the zero level, at the lowest level. Then the first level comes, you have sensors, actuators, fields, unit control and group control. Up to group control is the first level control. Up to here, this portion is unit, this level 1 control. You have what are the devices you use? You have sensors, actuators, and field control, unit control and group control. Above that, you have supervisory control, which is known as SCADA, supervisory control and data acquisition. We have this supervisory control here, so you control the computers have come into picture, and they take the data, receive the data from different sections, then process and control the data, and accordingly they generate the output, which is supposed to be the controlled or the automated output. Then comes the workflow undertaking resources, which is manufacturing execution. MRP, manufacturing is execution. Here is the third level. The second level was supervisory control. SCADA was the technology applicable there. Sometimes DCS is also applied. And then comes the third level, which is workflow, order tracking resources, tracking resources. And finally, then comes the fourth level. Fourth level is enterprise. Enterprise, production, planning, orders, purchase, etc. And the word called ERP. ERP is being considered here, enterprising resource planning, enterprising resource planning. And finally, the fifth level is known as the planning, statistics, and finance. That is the final level of control, and there a word is used called SAP. SAP is it is the simplest, simple as possible, simple as possible. Here, every automation is administrative automation. So you can see that large control system hierarchy gives you a very correct picture in industry that how lower level controllers are there. There we are using primary technology or a zero level control. Then we have the one level control, which uses sensors, actuators, unit control, group control. Whole lot of technology is being used here. Then comes the supervisory control, the SCADA or the DCS. Here we are getting all these signals from the lower level at one place, a central place, wherein we are incorporating SCADA. That software is there, which will take all kinds of inputs, receives all kinds of inputs from there, and then processes that input, and finally it creates, it gives the output, which is the controlled output, or we may call it the desired output. Then after receiving that output, it goes to workflow, undertaking and resources. So that is done at the manufacturing execution, manufacturing. Then one, that is the third level of control. Then fourth level control, as I said, is very, very important, which is enterprising. ERP is being introduced here. That means enterprising resource planning. And finally, above that, we have the total management or the administrative automation, which is SAP. It means it is the as possible, small, simple as possible. And here comes the planning, the statistics, analysis. This is the highest level of automation, and that will be known as the fifth level of automation. This is one thing I think is very, very important when you want to learn what is automation in industries. Then large control system hierarchy. The same thing what I have explained you from that figure: administration, enterprise, then manufacturing, supervision, group area, unit, field. And from this lower level goes to higher: field, unit, group area, supervision, manufacturing, enterprise, and administrative. This is the field level control. This is the actual equipment, the machinery. You can see this is the field level control. Is the direct integration, the direct control what you see here, right? With the plant's hardware. That is the field level control. Then group level, as I said, group level you have the group means so many hardwares at a time, that becomes a group. That means one was one unit, one hardware was one unit. Suppose there are 10 such units or 15 such units or many more units, then you have a group. You may have one group, you may have more than one group, two group, three group, four group, and so on. So that becomes group level coordination or group level automation. This is local human interface. Here HMI is coming, and the group level, so many group levels are to be interfaced with a human, and it will accordingly take the inputs, outputs, and process it with a bigger computer, and that becomes a local human interface. So one level higher, as I told you in the earlier chart. Sometimes the group level has its own man-machine interface for local operation control. Right. Then comes the supervisory level. As I said, this is the example of a supervisory control human-man machine interface. So you have all the data in the form of signals, different signals coming to this place. And finally, this unit, that is a supervisory level automation of the control, wherein human machine interface is a key, and all the inputs are being processed and the right kind of outputs are being generated. That output is a controlled output or a desired output. So this is the third level, or the supervisory control. SCADA is being used here, or DCS can also be used here. Then comes supervisory mosaic interfacing is still in use with direct wiring. Now here, what is the difference? Here the wiring, direct wiring is there, but nowadays the people are using wireless interfaces. So this is known as mosaic interface. It is many places this is being used, but one stage ahead is this. So it is known as supervisory mosaic interface, and here it is direct wiring. Wiring is available. And supervisory level SCADA, this is an example. People are working here. Now this can be wired, this can further be wireless also. Displays the current states of the process, displays the alternate alarms and events, display the trends and analyzes them, and displays the handbooks, data sheets, inventory, expert system, etc. Allows the communication and data system in others. Supervisory level. Then comes today's control room. Today's control room, and what is the difference? You see, technology wise there is a lot of difference. The principle was same. Here it is also being monitored, and it is being seen on that screen. But the main difference is that is whole lot is wireless, and earlier it was wired system. The system was wired. Here it is wireless. Projects replaces the mosaics. No direct wiring to the plant anymore. So it is it is a mimicry, and we mimic the whole functions which is being operated as in the plant in the screen, but without any termination of wires. So there is no connection. It is a total wireless control, and which is available in front of the people there sitting there and on the screen. So it is also known as mimic control. Plant management stores the plant and product data for further processing in a secure way. Although this is allowing to track the processes and trace products. This is known as Plant Information Management System, PIMS, Plant Information Management System. Make precautions on the future behavior of the processes, and particular about the maintenance of the equipment. Track KPI, key performance indicators. KPI is very important. It has to be tracked all the time. That is the key performance indicators. And asset optimization. Asset optimization is, these are the things which are being followed in industries nowadays. Very significantly followed. Engineering workplace, of course, it looks like this. Engineering workplace. Managing the control system, not the plant. This is the motto. You manage the control system, you don't manage the plant. The plant has been totally figured, you can say. It has been totally replaced or on the screen itself, and you try to manage that. So in other words, you can say that managing the control system, not the plant. You don't have to manage the plant, you have to manage the control system. The control system is in front of you, and that too is wireless, and you have to manage that. You don't have to bother for the plant. Task: configure networks and devices, load software, assign access rights, troubleshoot the control system, etc. These are the tasks being done at this level. So ANSI and ISA. One is American system and another is Indian system. So these are the codes, 95 standard classifications, level 4, level 3, level 210. Batch control, continuous control, discrete control. I have already described them in detail. The let it be a batch control or a continuous control or a discrete control. They come in 0, 1 and 2 level. All them control and command system. that come in the levels of 0, 1 and 2. Level 3 is the manufacturing execution system, MES, manufacturing execution system. So this comes in level 3, wherein operations and control, dispatching, production, detailed product, scheduling, reliability, assurance, etc. are being taken care. And the level 4, enterprising resource planning, ERP, that I said, is the business planning and logistics, plant production, scheduling, operation management, etc. That is level 4. And there is one more step ahead, one more level ahead, which is SAP, which is simple as possible. Simple as possible, that is totally administrative. So these are the 5 automation levels which have been defined by American system or by ANSI 95, ANSI, as well as by ISA 90. This is the example of power plant. So power plant will have different levels. You have seen this, field devices, then electrical systems, then contact control systems, then control rooms, and then office. The office is at the total, that is, here you have ERP, and finally you have SAP, and this is the total plant, which is at a very, very low level. So now we can see that the automation is at every level. It is not only at the technology, it is also in the management level. It is also in the administration level. It is also on the decision making level. So that becomes the total automation of an industry. And industry has to follow all these levels to achieve the best possible automation, to achieve the best possible desired outcome. This is another example of generic control Siemens. Siemens has given this kind of control. So they have processes at a process level. These are their language they have written. So automation, production, and enterprise. They have seen this automation. Then they have MES, as I said, manufacturing. They are seeing production, and they have ERP. So this is also an example of generic control Siemens have followed. If you have the response time, this is very, very important. Response time, if you see the response time, the response time and hierarchical level means the levels are PLC, programmable logic controller, which is a very lower level. It goes from millisecond to hours, right? Control level versus time. This is the response. So it is known as response time and hierarchical level. So we have control level, supervisory level, execution level, planning level, etc., etc. We have second, starting from millisecond to years. It goes up to years. So first, from millisecond to some hours, if you see the PLC, programmable logic controller, used. Then comes, there is an overlap, DCS, which is distributed control system. It can go from certain seconds to certain hours, more than hours, a few days also. Then comes the supervisory control, that is SCADA. SCADA goes from certain seconds to some more than some days, few days. Then comes MES, manufacturing execution system. It goes from certain hours to certain months. And finally, ERP, enterprising resource planning. It goes from weeks to even years. So that is the response time, and one can understand how important is this response time for the automation planning. You know, automation cannot be achieved without planning. So this kind of planning is very, very much required at every level, starting from the 0 level to the 5th level. As I said, basically there are 5 levels: 0 level, 1st level, 2nd level, 3rd level, 4th level, and 5 level. Level 5. 0 level is just the hardware. You can say PLCs, you can see valves, you can see relays, all kinds of hardwares which is actually being done at this level. Then comes 1st level, wherein we can have certain softwares, we can group them. One unit was separate. Now group 2-3 units can be grouped, or even more than 2-3-4-5 units can be grouped from group 1, group 2, etc. So like that it becomes then further. Then comes the 3rd level, which is known as your automation at the higher level. And then comes your ERP, where SCADA, wherein you have to get the inputs from the different units at a central place and then process the data, process the input data for getting the controlled output. That is the desired output. And then finally it comes ERP. ERP, sometimes it is said ERP is the final level, but there is, I can add one more level to it. ERP is the entrepreneur resource planning. Entrepreneur resource planning means market and everything. You have to plan accordingly. So you have to go your production in that way. But one more level ahead, which is the fifth level, is the SAP level, where it should be simple as possible. It is definitely only the administrative automation which comes here. So response time is also important. How to achieve the hierarchical level and how much time it is given, it is also very, very important to achieve the total automation. You cannot do that only in the technology wise achievement is automation. No, it is one application, then comes further and further. The total automation will come. It will be only possible if you have all kinds of level of control, all kinds of level of automation in your work. Data quantity and quality and hierarchy level, higher levels, data levels, lower levels. Higher levels when ascending the control, same thing what I have explained. Ascending the control hierarchy, data are reduced, high level data are created, processing and decision becomes more complicated, but timing requirements are slackened. At SCADA level, presentation of complex data to the human operator help to make decisions and mentally requires knowledge of database in addition to the plant's database. A lower level, lowest level are the most demanding resources. Time will be the most demanding, but quantity of raw data is large, processing is trivial, and these levels are today under computer control, except in emergency situations for maintenance or engineering. So what we can see is site, field, individual control, grip control, supervision, MES, and ERP. This is the complexity of hierarchical level. As you go higher and higher in the level of automation, the complexity becomes zero. Complexity is zero at this level, but complexity is maximum at this level. You can see the complexity is higher at the highest level of automation, whereas the reaction is the most less. It is just the reverse. The reaction speed is very, very less at the highest level, in months, days, minutes, seconds, right? So it will take more than a month to take the reaction, but at the lowest level it may be in milliseconds, as we have seen earlier in the time response. It may take millisecond to get a reaction, when then 0.1 second, then few more seconds, then minutes, then days, then months. But the complexity is highest at the most level, I mean the highest automation level, but the reaction speed is the lowest. Operation and process databases, you can see we can have process database, simulations, update, process input, plant, the instructor does it, and then logging, history, operator again gets the operator and it puts it on the computer, that is man-machine combinations or man-machine interface, and finally it takes the decisions. Process database and historical data. The process database reflects the latest known state of the plant. The historical database registers the events and happen in the plant and is therefore a collection of subsets. The process database part. A snapshot. Now I think I have given you quite a bit an idea of what is automation, how automation is required, why automation is required, and why automation, how much automation is required, what are the merits of automation, what are the demerits of automation, why automation exactly is required, where it is required, how is it required, and what are the level of automations. This I have dealt in detail, and now the house is open for question answer. Any questions you want, you are most welcome.